Okay, now let's look into some more details about electrical charge. Okay, so we learned that the rate of change of electrical charge will be measured in current. Okay, so we call it the rate of change of electrical charge. Okay, we call it um, current. Measured in I, okay, has a unit amp. Okay, 1 amp means 1 coulomb per second. Okay, so the rate of change of electrical charge. Now, I'm going to introduce you another concept called voltage. Now, what does it mean? So, okay, for voltage, so imagine. Okay, now what we do is um, let's imagine electrical charges, okay, as trucks. Okay, now let's go to next page. Now let's imagine, okay, we have little trucks. Okay, and each truck is 1 coulomb. Okay, now so okay now okay voltage. Okay, now voltage is basically imagine it as the load. Okay, the load of each truck. Okay, we call it a voltage. Okay, so how many uh, how many load can the truck can a coulomb carries? We call it voltage. So to really make it okay, so let's go back to understand it. Okay, now voltage is basically measured in volts. Okay, wave. Okay, so 1 volt, okay, is basically 1 joule of energy per coulomb. Okay, now okay, so um, yeah, okay, so I know we are a little bit confused about the term 1 joule. 1 joule is a measurement of energy. Okay, joule is a measurement of energy, and we will do it in great detail in second semester. Okay, when we're doing Newton's laws, when we're doing motions. But for now, just remember 1 joule of energy is equivalent. Okay, it's equivalent to the energy. Okay, energy we lifting an apple a meter above. Okay, lifting an apple 1 meter above. Okay, so that's the amount of energy considered roughly one joule of energy. Okay, so um, and yeah, I know it's a little bit confusing with current and voltage. Okay, current is basically the rate of change of electrical energy. So say okay, so the idea is okay, just imagine like this. Okay, so yeah, okay, charge. Okay, charge. Just imagine charge as those trucks. Okay, now if it makes um, so current, okay, means how many trucks. Assume all the trucks moves at the same speed. Okay, all the trucks electrical current moves at the same speed. We can't have electrical current move at a different speed in one material. So uh, imagine we have all those moving trucks. Okay, current means how many trucks are there. Okay, current means how many trucks. Okay, and voltage, okay, gave us the load on each truck. Okay, the more trucks I have, the more current I have, and the more load I have on each truck means the more voltage I have. Okay, so yep, try to, well, by the way, this is not 100% scientifically correct. Okay, but it's a pretty good explanation. Okay, just remember the relationship between this. Okay, the rate of change of electrical charge, okay, the number of electrical charges per second, okay, the number of trucks, voltage, how much energy does one electrical charge, okay, one coulomb of charge carries. Okay, again, we're not talking about electrons. Okay, also just remember, in this chapter, in electricity, we always going to use current and voltage. Okay, so just get familiar with them, and here is what they means. Okay, now let's look at the equations of voltage. Okay, so let me change. Yep. Okay, so just remember. Sorry. Okay, a voltage is basically equals to the energy, okay, divided by the charge. Okay, so uh, so we have volt. Okay, well, let me write down the unit. Okay, 1 volt is basically 1 joule per coulomb. Okay, now, okay, so W here stands for potential energy. Okay, now also let me introduce you something called the power. Okay, power is measured in current times the voltage. Okay, so if you look at the unit of current, it's basically 1 coulomb. Well, let me put it properly. It's coulomb per second. Okay, the unit of voltage will be joules per coulomb. If we times these two together, the coulomb got cancel out. Okay, the unit of power will be joules per second. Okay, so it's measured in watts. Okay, it's measured in watts. Okay, so if you look at your computer or television electrical device, okay, they have a power output or power input. So power is what they mean. Okay, power basically means, okay, well, it's given in VI, V times I, voltage times the current, and it means also if you look at the unit, okay, energy per second. Okay, so how much energy can it use every second? Okay, so that's how we find power. Okay, so yep. Okay, for this week, Okay, for this week, I really recommend you to make all the make a notes. Okay, make a notes of all the equations. Okay, well I introduced, okay, and what they mean. Okay, also the units. Okay, so um, yeah, this is really hard. Well, those questions, well, those concepts is really hard to understand. But once you go on to the question, try to do some, just do a few practice question, you should be alright. Okay.